Rightio, so here's my setup. We have input from the panels. They are coming in at 30 volts. Well, a little bit over, just depends on the sun. We have 7.5mm square of copper, and it's split between 5, so heat dissipation is quite good, and we're very unlikely to get the runaway effect. Okay, we have our input there from the panels to the batteries and our load. Now, internal here, the batteries and the load is controlled by processor in here, and they're not directly just hooked in one for the other. It doesn't work quite like that. My battery setup, we have two Trojan 12, one's a 1260 and one's a 1275, but I count them both as a 1260. That way, you know, a little bit less in here doesn't really matter, because when they're in series they work to the lowest capacity, or the worst battery is what they all are. So these are two 12s in series with each other to make 24 volts, and they are then in parallel with these two car batteries that I picked up. And always use a fuse, a 30 amp fuse there. And I need to get a nice big fuse between these two batteries there. So then we have our output and to our 24 to 240 volt pure sine wave inverter, which I got from Sydney. And shipped it up, cost me about 215, 220, something like that. And we're out. And so, yeah, I'll just flick through this for you to give you guys a look. So that's our battery voltage. That's the temp monitor. That little symbol there is input from the panels. Batteries are happy, they're fully charged and out to the load. That's how many amps I'm drawing in off the panels. That's how many amps are going on the load. That's how many amps have come in off the panels since I last reset the thing. And that's gone out. And that's our voltage off when the panels will switch themselves off. And we flick through again. That's our temp. So our panels will switch them off at 27.4. The load will switch on when the battery voltage gets to 24 volts. When the batteries get to 22 volts, it'll switch off. Load on 24 hours, so you can set up a timer. And we're back to the start again. So yeah, this one to my door cost me $44. It's 30 amp, 12 or 24 volt charger. So yeah, I always suggest using 24 volts because it's the amperage that matters for the internal circuitry. So you run a higher voltage as you can in the controller as you can, you'll get more power overall. Which also meant that finding a pure sine wave 24 to 240 was a little hard to find, and this is the only one that I could find in my budget. So 600 watts normal, 1200 watts for, you know, the power on spike that you get sometimes. So yeah, all in all it's been a pretty good setup and the panels work quite well. Alright, thanks guys, bye.